Hello guys, welcome to Pepcoding, and today we will gonna solve this question, solve Sudoku. So this is a very ideal question of recursion and backtracking. So we will gonna solve it. So the flow of the question will go something like this. First of all, we will understand what the question statement is. Then I will tell you what is the approach we will gonna use for this question. At last, we will gonna code this question. And if you directly think about this question, it is a very hard question. But if you break it in small pieces, this question looks very easy. So just be with me and I'll explain you how to do this question in a very easy manner. So first of all, let's understand the statement. So if you are given a partially filled 9 by 9 2D array. Okay, so that means partially filled 9 by 9 2D array. We have given a 2D array, okay, which represents an incomplete Sudoku state, which is in incomplete Sudoku state. All right, and you are required to assign the digits from 1 to 9. I have to assign what? Digits from 1 to 9 to the empty cells, the cells which are empty. But the thing is, which cells are empty? 0 represent an empty cell. Here it is written 0 represent an empty cell, okay. And we have to assign the digits in such a manner that there are 3 rules. Rule number 1, digits from 1 to 9 must occur exactly once in a row. Means no two duplicate and the digit cannot be repeated in the same row. Second, digit cannot be repeated in the same column. The third is digit also cannot be repeated in the subarray. These are the 3 rules, and we have to follow these rules to do this question. All right, now let's get to our open board and I will teach you how we can do it. And it's an easy question, don't be so over dramatic about it, okay guys. So think about it, this is the kind of input we have given. We have given this kind of something array. All right, and we have to do what? We have to fill these boxes which have 0. 0 means what? Empty. 0 means what? These are not vacant. Sorry, these are vacant. These are empty boxes. These are empty places. No one is here. So we have to fill these boxes which are empty. Okay. Now we will gonna understand how we can do it. So first of all, what I will gonna do here is I will put levels. I will put cells over levels. At every level, I will put some cells. Okay. This is the flow we will gonna use. So first of all, let's try to make a tree about it, and after that this question will look very easy to you guys. Okay, so let me put my pad here. So first of all, let's understand about this place. This is what? This is the place number 0 comma 0. I am right now currently in this place. Okay. So here I have 0 at my level number 1. From now, here you can see that this place is not vacant. So this place has already filled with 3. So I cannot do anything. I just move to another place. So from 0 I go to 0 1. Now 0 1 has options. Like 0 1 has option for 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 1 has options for all the 9 possibilities. So from 1 to 9, right? Now let's try to put. Can we put 1 here? Can we put 1 here? 1 is 1 in our row? No. Is 1 in our column? No. So we can. And is 1 in our submatrix? No. So we can put 1 here. Now after putting 1, we move to our we move to our this part 0 2. Okay, now we are at 0 comma 2. At 0 comma 2 we have to do nothing because it is already filled. Now 0 comma 3, nothing is here also. Now 0 comma 4. Okay, at 0 comma 4 we again have options. So from 1 to 9 it has all the options. Now let's see which option can be filled here. So what about if we fill 1 here? Can we fill 1 here? No, 1 is already here. Can we fill 1? No. Can we fill 2? Is 2 here? No. Is 2 here? No. We can fill 2, yes. Then after that we have to, okay, then we put here what? 2. We put 2 here. After putting 2 here, we move to 0 comma 5. First of all, let's move this tree a little downward. Okay. And little this side. Okay. So at 0 comma 5, we are at 0 comma 5. It is already filled, right? From 0 comma 5, we have to go to 0 comma 6. It is already filled. Then 0 comma 7. At 0 comma 7, this is what? Vacant. If this is vacant, 0 comma 7, this is vacant, right? So we have to fill it something. Can we fill 1 here? No. Can we fill 2 here? No. Can we fill 3 here? 3 is already here. 4, no. 5, no. 6, no. 7. Can we fill 7? No. 8, no. 9. Okay, no, nothing in 9 in the row, no 9 in the column, and no 9 in the submatrix. So we can fill 9 here. Now let's move to this part. What can we fill here? Can we fill 1 here? Okay, at 0 comma 7, let's move our tree again, now a little backward. So from 0 comma 7, we put what? We put 9. And after putting 9, we are at 0 comma 8. Now what we can put in 8? Can we put 1? No. Can we put 2? No. 3, 4, no. 5, no. 6, no. 7. Yes, we can put 7 here. But think about one more case. I have already put 7 here. Here is no vacant place now. Okay, and here is, we have to put something. So now can we put 7 here? No, we cannot put. Can we put 7 here? No. Can we put 8 here? No. Can we put 9 here? No. If there is no place left to put anything, what we will do now? The problem, right? So for this problem, now understand what we need to do. We move in this array something like this, right? We move to this and we filled with 2 here, we filled with 9. Now there's no place to go. What we will do? We will come back. And as we come back, what we will do? We will just clear our footprint. Or what I can say, we will clear our footprints. So we have to remove this 9. When we come back, we have to remove this 9. All right. But is there any option left here? Else 9? No, there is no other option than 9. So we have to move more backward. Then at 7, at 6, at 5, then at 4. When we come at 4, we again remove this 2. And then we again check if there is any other option for us. Let's check. 2 we cannot fill. Now let's check for 3. 3, no. 4, no. 5, no. 6, no. 7. Can you put 7 here? Yes, we can. So from here, now it makes a call to 7. Now our call will go to 7. After putting 7, we again go to 0 comma 5. This is already filled. So we again go to 0 comma 6. Then we again go to 0 comma 7. Here we again check. Can I put 1 here? No. 2 here? No. 3 here? No. 4 here? No. 5 here? No. 6 here? No. 7 here? No. 8 here? No. 9? Yes, I can fill 9 here. So here again I will put what? 9. 0 comma 7. At 0 comma 7. Sorry, and come to 0 comma 8. Here then I again check for any word. The thing is, the concept we are using here is we travel towards the whole matrix. First of all. Second, we check at every place for every possibility. Like we check for 1 to 9 for every number. And when coming after placing the number, if we come back, if no options left for us, we do what? We remove our footprint and then we move to another option, as we did in here. When we left our option, we go back, and where we get another option, we try to go through it. And this is how we will gonna fill this whole structure, whole matrix. Easy. Now you got it. Okay, so there are some things which you need to remember, which you need to understand. First thing is we need to do what? Travel through matrix. So we use through matrix. This is important. Now second part is check for every possibility. Check for every possibility. After checking for every possibility, then what we will do? We check for every possibility here, and after that, check for every possibility. Travel through matrix, check for every possibility. We go for when if options left, options and we do what? Backtrack. And one more thing is here, if we when check for every possibility, here there is one more thing, that we have to put our value, put the digit, but only if valid. If the digit is valid, only then we will put it. Okay, now let's move to our coding part, and we will just code this question. It's an easy question, by the way. So here we have to complete this function, which is solve Sudoku. What we have given is, first of all, we have given this 2D vector with the name of ARR, and then we have an input here. Then at the solve Sudoku, we have given what? 0 0. This 0 and this 0 is I and j. At the initial position, our I and j is at 0 0. From 0 0 we have to move, right? So now here we have to do our code now. Maybe at first you won't understand the code, but trust me, if you stay with me, I'm gonna explain you every single thing. So first of all, I do is I will make two variables, new I, which is I initialize with 0, and again int new j, which I initialize with 0 again. After these new I and new j, I will check what? If j is equal to board. I will explain you everything, just be with me. Board dot size -1. If this happened, if something like this happened ever, we do something, else we will do something. This is the main thing. And after that, there are two more conditions, which is if board at I j is not equals to 0, we will do something, and again else we will do something. Now let's understand both of these conditions. First is new I and new j. The thing is, just see here, if I am at this point, understand, I am at this point, I have to move in the matrix, right? So my new I and new j will be, if this is our old I and old j, which is I and j, so it was 2 comma 2. At first I was at 2 comma 2, but in the next recursive call I should be at here. So new I and new j, ni and nj are this point. So this point will be what? 2 comma 3. So here I have to increment my j plus plus. But think about one more case. If my I and j are here at this point, which is what? 5 comma 8. But in the next point, I don't want to increase my j. I want to do what? I want to increase my row, and I want to make my j 0. Right? I want to do what? I want to make 5 to 6, and I want to make this at 0. So this is the condition I am tackling here. These are the conditions. New and new j are the points for our next recursive call. Right? So if we are at the end of the board, if our column is at the end, what we will do? We will increase the ni as I plus 1, and we will increase the column as 0. We will make the column as 0. But else what we will do? We will just increase our column. These things are done too. Now comes this part. If there is no 0 at that spot, what we will do is solve Sudoku call. I have to make my recursive call, and I have to do nothing. I will just pass my new I and new j. It's done. Now comes the else part. At the else part, we have to make a for loop again. In the for loop, I have to do what? Int value. I have to check for the all options. And value is smaller than or equals to 9, and value plus plus. This is done. Hey, I have to check for all the options from 1 to 9. Every cell has the every option. This is what I'm doing here. I'm checking for every option. Here I will check if is valid. If is valid, board at I, comma j, comma value. If is valid is this. Here I have to make the call. I have to do what? Board at I j is equal to value. Then I have to make my recursive call. Solve Sudoku. And here what I have to do is same. Board, comma, next I, comma, next j. After that I have to do what? I have to backtrack and I have to change it again. I and j is equal to 0. And after this, we got our board. So first of all, understand this much here. What this is doing. First of all, we have to check. We have to check if the place we are trying to put our digit is valid for that digit or not. So if it is valid, we put that digit. Then we make our recursive call, and then again, if somewhere in the future we have to backtrack, we have to remove our footprint. You have to again put 0 here. Now the only thing left is valid function. Okay, now let's try to make this function also. This is also an easy function, not a problem here. So the thing is, I have to do boolean. It should be as boolean is valid, and it should get vector of int at the rate board, comma, int x, comma, int y, comma, int val. This is done. Here is valid is giving us if this value is valid or not, right? So first of all, what we will do is n is equal to board dot length, board dot size, sorry. I get the size. Now I have to make a call for what? For the column. That is this value is in our column. So for loop int I is equal to 0, I is smaller than n, and I plus plus. This is done, and I have to check if at anywhere in this column, if board has this I, this value, we have to return what? Return false. Here x is constant. Why? Because we are checking at column. So if we are checking at column, we should put x as constant, right? Then comes the second part, which was for vertical. Now let's check for vertical. At vertical, we have to do what? At vertical, we have to make this y and make this as I. And vertical is done. Now comes the main part, which is submatrix. Matrix. Now let's try to do this in submatrix, and before that I want to tell you a formula. Okay, that is an important formula. So understand how we can travel through the submatrix. First of all, let me tell you how we can travel through a matrix. Right? So let me make something first. I will make very fast. Okay, put this here. Okay. So I have to make, I am making every submatrix which is present right now in this array, in this sub array. So put this, then at third, divided by 3. This is also 3. Then here is another, and here is another. So these are all the 3 9 submatrix this matrix have. So right now, let me tell you a formula. But before that, let me remove this first. Okay, remove this also. Now we are just focusing on how we can travel through this submatrix. So for that, first of all, let me take a number. Let's take this cell. Is that 4,5? 4,5. Now think what I will do. I will do 4 divided by 3 multiply by 3. I will do 5 divided by 3 multiply by 3. What I will get is, this is, I will get 3 1 into 3. So I will get 3, and this is, I will get 3. Okay, so this will give me this 3, 3 this 3, 3 coordinate, right? Now let's take another one. Let me take you. Let's take this number. This is 6 comma 1, right? So let's do this. We are at 6 comma 9. Sorry, 6 comma 1. Now again let's do this. 6 divided by 3 multiply by 3. 6 divided by, sorry, 1 divided by 3 multiply by 3. Here I will get what? Here I will get 2, 6, 3 into 2, 6. Here I will get 6. And here I will get what? Here I will get 0. Now understand the coordinates. This is what? 6 comma 0. 6 comma 0 is what? 6 comma 0, this. Now let's take another matrix, another coordinate, which is let's take something like this one. This is 5 comma 7. Again do the same thing. 5 comma 7, do the same thing. 5 divided by 3 multiply by 3. 7 divided by 3 multiply by 3. What this will give? This will give us 3 into 2, 5. So wait a second, which number? This is the digit we took now, right? So if I divided by 3, 5 divided by 3 is 2, sorry, 3, 1, 3, and 3, 2 into 3 is 6. So 3 comma 6. This is what? This is this coordinate. So there's one thing here, that with this formula I'm always getting the corner point of subarray, right? And from the, and one more thing, if I get the corner point, I can travel through these numbers. Okay, so this is my formula to travel through submatrix. I'll get the row number and column number. I'll get the corner point from that number, and then I will travel through this submatrix. Now let's do this. This is also an easy thing to do. No problem at all. So first of all, we have to get our corner matrix. Like, so x divided by 3 multiply by 3. Y is equal to y divided by 3 multiply by 3. This is done. Now comes the main part. I have to make for loop, for into for loop, for loop, right? So for int I is equal to 0, I is smaller than 3, and I plus plus. Then again for int j is equal to 0, j is smaller than 3, and j plus plus. And at last I have to just check if board of x. Now understand this thing, that I have to check if this is valid or not. So board of some place is equal to value. If I get this value, I do what? Return false. And if everything is correct, I have to return what? True. But this place is valid. So now check this out. X, we take x divided by 3 into 3. Y divided by 3 into 3. I got the corner point. From the corner point, I have to do what? I travel through I 3 times, and then again from j to 2 times. Now I can do what? I can just make x plus I and y plus j, and by this formula I can travel through the submatrix. Okay guys, now let's try to run this code. And one more thing, before running the code, there is one more problem here. We haven't put the base case. So let's think about the base case. So at some point, after filling up every point till here, our pointer will get to this row, and at this row I have to do nothing. This is our base case. When I reach here, this is our base case. Now let's try to put this base case here. So here I have to do what? If I is equal to board dot size. If I reach there, you have to do what? You have to display board and do what? Return. Now let's try to run this code. It should work fine, or if there is any compilation error, we will gonna resolve it. Yes, there is a compilation error at 45. This is saying return is return. Okay, if board dot size is display board, there shouldn't be any issue. Because we have a wrong answer, so let's try to check what is wrong in our code. So okay, here is valid is this. So if board is equal to x, I get my thing that this is what where we are wrong. you have to put double equals to. We also have to put double equals to here. Then again you also have to put double equals to here. This is where we get wrong answer, right? So now let's try to run this code again, and I think this is the correct one now. All right, accepted. So let's try to submit this code. Let's see if it works for all the test cases. And perfect answer. So guys, this is how you have to do solve Sudoku. We have to do it in parts, right? First of all, you have to check what we should do here. We can use backtracking here, right? Then I have to make the recursive calls. Before making recursive call, I have to do what? I have to check if that place is valid or not. So this is that recursive problem. But if you understand the explanation, if you understand what I told you, so please like the video. If you have any query left regarding this question, please comment it out and subscribe to our channel. Thank you so much, guys.